All right, hello, 11.7 solving nonlinear systems. So to start off with, we're going to look at some nonlinear systems. So similar to how we did systems of equations with two variables, now we're looking at some that are not linear. This means one or both of the equations is not going to be a straight line anymore. So we use substitution or elimination method. We can also graph. So these are some options. So this would be a parabola and a line, and this would be a hyperbola and an ellipse. So these are samples of types of systems. So we're going to do a couple together. I'm going to have you practice some, and we'll go like that. So this first one is a parabola, and we know from the same rules we looked at last class. I'm going to put it in standard form. So this is negative x squared plus 4. Okay, and then for the second one, this is a linear equation. It's a line, y equals mx plus b. So when I go to graph these, the parabola, this first one is a y equals parabola, which would be arrows up or down. In this case, I'm going to have the arrows facing down because there is a negative in front, right? That's a reflection. So this parabola would start at a vertex of 0, 4, and my arrows point down. So I'm going to do my same pattern that I normally do, 2, 4, and then 3, 9, 4, 8, 9, 9. So this is my parabola, and the straight line is linear here. Let's scoot this one in a little bit. The straight line is a linear function. And in this case, my linear function is going to be y equals x minus 2. So I start with my y-intercept, and then I follow my slope 1 over 1. And you can kind of already see where these points are going to intersect. Just going to keep marking this out a little bit further so I can get as many as possible. You want to fill this coordinate plane here, as many points as possible. So I can see 2 points right here and right here. See where they intersect? That is the system solution. So we'd write system solution. And we now need to find that system solution. So first system solution would be negative 2, 0. And the second system solution would be 1, 3. So I have 2. Okay. All right, let's look at the next one. So next one, I can identify looking at it right away. This is a circle, and the radius is 3. And the second one down here is a line. Once again, it's a linear function. And we have y equals negative x plus 5. So my circle at radius of 3 starts at the origin, and then the radius is 3. Let me connect these to form a circle. Push and hold. Okay, there we go. And next, I have a line that I'm going to graph. I start at y-intercept of 5. Then I go down 1, right 1 across this diagonal. I want to mark as many points as I can here. And then remember, a system is looking for where these points intersect. So I'm going to look. And if I look, notice how there's a gap between these two curves. So that means that there actually is no system solution, right? See how there's a gap right here? So this gap means there is no solution. So we say no solution to this system. No solution to this system. Okay, we did 2 of them. I'm going to have you practice a couple here. So why don't you guys try the bottom 2? Oh, here, I'll pause for a second. Go ahead, pause, try the bottom 2. All right, thank you so much. Hopefully you tried it and you were able to get these 2 answers. I'm going to zoom in to show you. So the first one, we do have a parabola, and the second one is also a parabola. They are both horizontal parabolas, right? Which means they are sideways parabolas. I went ahead and labeled one of the equations. I can label the other one here, y squared minus 5. So these are my two parabolas, and notice they do intersect at the 2 points there, so I do have two system solutions. Okay, the other problem we had, here we go, right here. This was the solution. So you had a hyperbola and an ellipse. And remember, hyperbola, we know it's a hyperbola because it's a minus sign in between. And anytime you have minus signs in between, that's what gives you the hyperbola. So x squared minus y squared, this is a hyperbola, right? This is a hyperbola because it's a minus. Okay, next up we have our system solution, and we have 4 points where they connect. So this one you might have had to graph very carefully to be able to hit those actual points. So just graph it carefully when you're doing these, and this is an example. So this one is an example where actually solving algebraically would be better for us. It would be more efficient. So that's an example where if you were given the option, I would actually recommend solve algebraically, do not solve graphically. Okay, so we're going to practice that. So right here, algebraically. So let's tackle a couple of these again, and then I'll have you practice. So solve the system algebraically. So first part we're going to recognize. So when we're solving algebraically, it doesn't fully impact us what shapes we have. We can still look at these and decipher what they have. So like the first one looks like it would be a circle, right? But because there's a divide by 2, this is really going to be an ellipse, right? So it's going to be x squared over 4 plus y squared over 2 equals 1. So that's an ellipse. And the second one is going to be a hyperbola. And we don't want to graph these. We're solving algebraically. So I want to think about, what can I do to get these two equations? I want to line up the variables. I'm going to leave it in this form because my variables are in a line. And I want to eliminate a variable completely. So I have a couple options. I can either multiply the entire bottom row by a negative, cancel out the x. I can multiply the entire bottom row by a 2 and cancel out those y's. So if we do this method, let's see, x squared plus 2y squared equals 4. And then I have 2x squared minus 2y squared is equal to 8. So when they cancel, my 2y squareds are going to completely cancel. I'm going to end up with 3x squared is equal to 12. So x squared is equal to 4. So x is equal to plus or minus 2. So I have two answers now. X is equal to plus or minus 2. So I'm going to need to plug this in, right, for my y variable. And I have two possibilities. So let's see, which one do we want to plug into? Maybe the second one looks a little smaller, maybe? I mean, I guess it doesn't matter. We could do the first or second. So if I plug in x squared minus y squared is equal to 4. So let's plug in both of them. So I'm going to say x equals 2. X equals negative 2. So x squared minus y squared equals 4. Here we go, solve for the y. So when I plug in positive 2, 2 squared minus y squared equals 4. So 4 minus y squared equals 4. So this is y squared equals 0. So y equals minus 4 minus 4 is 0. So y equals 0. And over here for negative 2, I get negative 2 squared minus y squared equals 4. So I get 4 minus y squared equals 4. So if I plug in again, I get, let's see, negative y squared equals, so 4 minus 4 is 0. So y squared still equals 0. So I'd have two answers. So my system solution would involve these 2 points. I'd have negative 2, 0, and 2, 0. And it is possible to have more than 2 solutions, right? In the graphic example, we actually had one that had 4 solutions. Okay, so there's one. Let's try another. Here we go. So this time, let's see what we have. The first one is a parabola. And this is an x equals parabola. right? So it's a horizontal parabola. Horizontal parabola. And the bottom one is a line. It's a linear function. It's a straight line. Okay, so how can I go about? I notice that I have a singular x in both of these. So I could use substitution if I want. And that might be the best option for me. So if I'm substituting, let's see, this second equation, I could have x equals 2y plus 4. So now if I use substitution, right, I'm going to substitute back into the first. So y squared is equal to 4 minus that x. So I'm going to substitute back in for this x. And don't forget parentheses. So 2y plus 4, I now need to distribute. So y squared equals 4 minus 2y minus 4. Well, the 4's and minus 4 cancels. So I really have y squared equals negative 2y. Right? So let me group it all to one side. I can factor out a y. And I have two answers. Y equals negative 2 and y equals 0. Okay, I need to plug it back in. I'm going to plug it back in into which one? I suppose it doesn't matter. I could plug it into either one. So let's see. X equals x minus 2y equals 4. Okay. So if y equals negative 2, then I would have x minus 2 times negative 2 is equal to 4. So x is equal to, this would be 4 plus, oh, nope, this would be x plus 4 equals 4. So wouldn't this be x equals 0? All right. And if y equals 0, then I would have x minus 2 times 0 equals 4. So this would give you x equals 4. So once again, I have, here's two solutions. System solution. And I have, let's see, 0, comma, negative 2 and 0, comma, 4. Okay. All right. How about you try the bottom two? So you guys go ahead, pause, try these bottom two. All right, thanks so much for coming back for us. You ready to see your answers here? Okay, so here are the first two we had. And if we see, we have our, oh, did I flip my X and Y? Ooh, I flipped my X and Y, guys. Look at this. Our system solution. Yikes, good catch. All right, so there you go. Make sure you go ahead and correct yours. Make sure you have it right. Whew. All right, and the other one, let's just check the other one. X is right, Y is right. Okay, we're good. Okay, so back at it, sorry. Here's our second problem. Go ahead and check your answers here. The left one was a little bit tricky. Yep, the first one was a circle. And the second one was a parabola. And this was a y equals parabola, so the arrows would be up, right? A vertical parabola. But when you substitute them in, you notice that you have to end up using the quadratic formula, right? And you end up with an imaginary root, a complex root. So there is no real system solution. There's no real number system solution. And for part D, when you plug this in, you actually can use elimination, which is nice. And you end up getting 4 total answers, which is a pretty good amount. So 4 total answers. Okay, so here's what we're going to do. I'm going to have you pause. There's 2 partner activities. I'm going to show them both. So take your time, and then you can pause the video whenever you need. So go ahead and work on this set. All right, here's your answers. Thank you so much for coming back. Go ahead and check. I think my answers are good to go, but if you notice any typos, send me an email. Let me know if by any chance I have any typos anywhere. And then the next one we have, we're going to go ahead and 6 and 12, you could do either way. You could either graph or solve algebraically. I only put one of the option solutions on here. If you wanted to see the other, let me know and I can show you either way. All right, And then here's your second set of partner activity. Determine which equation you'll have and then graph each of them. So go ahead and, this is recap. This is just one. Okay, and here was your answer. We might have actually done some of these problems, but I just want to do one more to really like emphasize. It's kind of a recap. Okay, and this was it. You guys are good to start on your homework assignment. So go ahead, if you keep scrolling, here it is. I have your assignment listed for you. Yeah, try to get through as many as you can. Yes, please do all the problems. All right, have a great rest of your day. Bye, guys.